Hello everyone, welcome back to Maxim Automation. Today in this video, I'm going to discuss the fourth principle of SOLID, which is the interface segregation principle. We'll discuss what this principle says and how we can implement this in our framework. So first, let's talk about what this principle says. It says that no code should be forced to depend on methods it does not use. So according to ISP, we need to split interfaces that are very large into smaller ones so that the clients will only have to know about the methods that are of interest to them. This principle is similar to the LSP principle which we discussed in my last video. The major difference is that LSP talks about inheritance while ISP talks about interfaces. Now let's understand this principle by the example. So here I have this interface called as iCard, which is basically the interface for payment cards like debit or credit cards. This interface contains card-related operation method like card number, card fees, expiry date, and card PIN. Now let's say I have to create a class for debit cards which is going to implement this interface. So I'm creating a class for debit cards. And now this class implements the interface iCard. Now because this class implements this interface, so we need to implement all the methods available in this interface. So this class is gonna implement all these methods based on its business requirement. So far, this class does not violate the principle because this class debit card needs all the methods available in the iCard interface. And it's gonna implement each method available in this. Now let's say in future, there are more features to come and we need to add another type of card service as credit card. This service is also a payment method but can have more or less operations. To develop this new feature, let me add the new methods to the iCard interface. So a credit card will have one method for the credit limit. Then it will have one method for payment due date. Credit card also have reward amount facility. So I can add one more method here for reward. Now let me create a class for credit cards, which will implement the iCard class. So here I can implement the iCard interface and then will implement all the methods provided by this interface. Now this credit card class will work fine as it is gonna have an implementation for all these methods. But because I have changed this iCard interface and added more methods, so all the classes which implemented this iCard interface, now I have to implement these new methods as well. So if I go to the debit card class, and now let's implement the new methods added in iCard interface. Now the problem is there are these methods which do not require any implementation from debit cards because debit cards do not have any kind of credit limit and there is no such operation for payment due date. So now this class violates the principle because it's implemented the method which does not have any requirement by the debit card. And because these methods do not have any logic, so I can throw an unsupported operation exception. This is how I violated the principle because the ISP principle states that no code should be forced to depend on methods it does not use. So here we don't need these methods but are forced to implement. Now we'll see how we can refactor our code to make it ISP compliant. So according to ISP, we need to split interfaces that are very large into smaller ones. So I'm gonna break this iCard interface into two. One is for debit card and another is for credit card. Let me first create an interface for debit card. And after that, I'm going to create another interface for credit card. Now I have these two new interfaces. One is for credit card and another is for debit card. So now in the iCard interface, I'm going to only keep the methods which are common to each type of payment card and need to be implemented by both of the card types. So I can keep methods for card number, card fees, card expiry date, and card PIN. And rest all methods are required by the credit card. So I'm gonna cut these methods from here, and then I'll just place all the methods over here in this iCredit card interface. And also let's extend the interface iCard here so that we can have the basic methods of a card along with the methods specific to the credit card. Now let's move to the iDebit card interface and extend the iCard interface here as well. And then in this debit card interface, I can add the methods which are only applicable for debit card. Let's say, for example, debit card can have the available balance amount, while in credit card, we don't have any balance amount. In credit card, we can have the credit amount or credit limit. So for all debit related operations, I can add those methods here in this interface. Now let's go back to the debit card class and remove all these methods. After that, let me change the interface here from iCard to iDebit card. And then I'm going to implement all the available methods. Here you can see now it displays all the methods which I'm going to implement. These methods are from iCard interface, and this method is from iDebit card interface. So as I'm going to have the implementation for each and every method here, so this class now does not violate the ISP principle. And now let's go to the credit card class. Here also, let me change the interface from iCard to iCredit card. Now, this class is also going to have the implementation for each and every method. So this also now does not violate the ISP principle. So this is how you can implement the ISP principle by dividing your interfaces so that any class which implements the interface are not forced to implement any unwanted method. And dividing the interfaces will also help in achieving the next principle, which is D in the solid. We're going to discuss it in detail in my next video. I hope you liked it. Please put your comments in the comment box. Also, please do not forget to subscribe to the channel. Thank you.